So, everything started.
Muted.
Okay. In the last class, we've seen about what SAP HANA is here. We could understand that it's just an in-memory database here, where it does store and process data in main memory, and it is also an appliance where it is a software comes along with the hardware, and it has got its own access engine where you can develop and deploy your applications and run on the engines, and does have its own web server which can respond to the requests coming from the web-based viewer. Yeah, that's what HANA is. And then we went on seeing about HANA use cases, just trying to understand how can we leverage SAP HANA. Like we can use SAP HANA as data mart, where you install HANA as a centralized database and you do the data provisioning from different SAP or non-SAP or legacy systems through BODS or SLT, DXC, Smart Data, Smart Data Quality Integration, and then bring all your data into HANA database tables. On top of these tables, you start doing HANA-based modeling by creating attribute views or analytical views, or go about creating calculation views either with SQL-based or graph, and expose them for reporting. And HANA basically exposes the objects with SQL interface and MDX interface. And any reporting tool which can consume objects through SQL or MDX can be leveraged for reporting on top of SAP HANA. That was as data mart.
Unmuted. Muted.
So can you hear me now? Can you hear me? Yeah.
Unmuted.
See, what?
I know. No?
Can you hear me now?
Muted.
Hello? Okay. Okay. So maybe, and we could use HANA as database. Like say you have existing applications like BW, ECC, CRM, APU. All those applications can go about sitting on HANA database also. Then we looked at where we combine leverage HANA as database for SAP applications, and the same HANA can be used as for data marting. And then we could see we could even use HANA for developing your own custom application with native or non-native also. And we can have SAP cloud. If it is a cost factor, we can also use HANA on cloud also. So that was use cases. And there's been a lot of buzz around HANA about the performance, what it is giving, right? So we're trying to understand now, why is this HANA so fast? Yeah? No, it's not just about in-memory, but there are lots of the reasons. Now, so what makes SAP HANA fast? We're trying to understand what are the different aspects within the HANA database, which is resulting in high performance of the results. Now, there are a couple of hardware innovations which is resulting in high performance, and there are a couple of software innovations which is resulting in high performance. Now, when it comes to hardware innovations, it is with multi-core processing, multi-core parallel processing. We'll get into details of that. And having your data in main memory. They say that now the costing of your main memory has gone down when compared to previous years. So why don't we leverage RAM itself as a data staging area? Because if you have your data in the disk, the time taken to read from the disk is much more, 1 million times slower than reading it from main memory. Having this point, so they're trying to use leverage main memory for data staging of the. Those are two ones from the hardware. If you look at from software, there is something concept called row and column store. These are like two types of tables. row store table, column store table. Very, very important. And there's a database called Sybase. This had a type called column store table. SAP took over Sybase, and the concept of column store has come into HANA database. And column store has really changed the way how the data has been staged and the performance on the reading on the table also. Very, very important. Then compression. SAP HANA does use a lot of compression techniques where you store huge data with less space. So it has been proved in the labs or with other implementations that if it is taken, if your footprint is 100 GB, let's say in Oracle, you're storing, it is consuming 100 GB of data, and if you bring the same, if you lift and shift your data to HANA, it is going to consume 20 GB. So to almost 5 times the data has been compressed because of the column storage. We'll see what it is. Then partitioning of data onto multiple nodes. Okay. Like say, if you have multi-node architecture where you have multi-server, multi-board, multi-motherboard, then you can basically have your table partitioned across the boards. Okay. We see. Then there's something called we're not no more going to use aggregates. If you look at BW, you build a cube again, you go but end up creating some aggregates. Now, do we have a limitation of aggregates saying that does hold data duplicate in both redundantly in cube and your aggregates? So we can eliminate that if it is BW or HANA. And even if people who look at BO, you know, like say if you're creating some universe on a non-SAP tables, you create some detailed tables and summary tables also. And then you use some function called aggregate awareness function. In IDT, they use something called aggregate awareness function. Depending on the query, it would read from the summary table or detailed table depending on the navigation. So they use that aggregate awareness function. So all the summary tables concept can be eliminated. What SAP says, you store it in any detailed form. I will handle the performance. You just dump the data into the table. It could be denormalized. It could be any detail. I will handle the performance. That's what again benefits, because if you have aggregate, you go about storing data redundantly or duplicately and wasting your space. And by eliminating aggregates, we're able to reduce the database footprint, what you go to bring into HANA base. Now let's get into each of this. Now, what do you mean by multi-core processing? Yeah. Now, normally everyone would have brought some system, right? When you buy a system, heard about these words like say, is your system dual core, quad core? You heard about those words? Yeah. So when you say dual core, it means you'll have a motherboard, you'll have a processor, and processor will have 2 cores in it. And when you say 2 cores, 2 processing can be done at a time. When you say you have a dual core system, it means 2 operations can be carried on parallelly. That's what it is. That is what dual core. And compared to dual core, quad core is faster because you have 4 core. Quad is 4 cores in the processor. Means 4 operations can be done at a time. Getting this? So we had dual core, quad core, right? Now it is the hardware has been advanced to the level where now here I'm saying, look at this. I can have a motherboard with 8 CPUs, but already again there is a latest development where they're able to have one motherboard with 10 CPUs already. You'll have one motherboard, 10 processors in it. And each processor can hold 12 cores into it. So core is actually that part of the CPU which actually does your operation. So when I say I have a processor with 12 cores, means 12 operations can be done at a time. That's what parallel at a given point of time, I can process 12 operations with 12 cores, and each core does your operation. Clear? So imagine a motherboard with 10 CPUs, 10 processors in it, and each processor holding 12 cores in it. And how many cores do you get now? 120? Okay, let's say 8 CPUs. So 8 into 12, 96. And let's say if I'm not happy with the kind of sizing, I can even go with multi-node implementation where I'll have, let's say, I combine 4 motherboards into it. So if each motherboard is delivering me 96 cores, and if I combine with 4, 96 into 4 would be the cores of what I would get. Approximately something like 250, something like that. Means I can have 250 operations done at a given point of time. That too parallelly bus. While writing your SQL script or while writing your programs, you don't write anything or execute parallel or something. It is all intelligence of the system of executing things parallelly. Let's say I've got statement 1, statement 2, statement 3. If these can be executed parallelly, system intelligence will identify that this can be run parallelly, so it executes parallelly. If you don't want it to run parallelly, you have to explicitly start writing a code saying execute sequence. Otherwise, by default, it is a parallel execution. Okay. So if you're trying to understand what is parallel execution, let's say I have a table with lots of columns. Let's say I'm trying to write a select, I'm trying to query my database. I'm writing, say, select column A, column B, column C from table. I'm trying to read 3 columns from the table. Yeah? So you would get to see the results. But internally, to speed up the processing of this query, what system does is the process of reading data from column A will be designated to core 1. The process of reading data from column B will be designated to core 2. And let's say again understand that the cardinality, the values of column C is huge. It does do horizontal fragmentation. Means it does split that column again 2 parts and assign the part 1 reading into core 3 and the data of reading for core second part would be by core 4. It is all done automatically. You don't do any writing, no coding, nothing. Yeah? So splitting each column for different core, we call it vertical fragmentation. And the same column is split into further parts, we call that as horizontal fragmentation. It does do that. And the reading of this cores or data from 2 different cores. And you'll have 4 cores playing on this to read data from the table, combine its results and give it to you. Logically, ఒక మనిషి చేసేకి నలుగురు చేసేకి తేడా ఉండదు. So now what's happening now? 4 cores are getting involved in reading data for my query. Obviously, I should see good performance. What I mean is multi-core parallel processing is the hardware innovation. It's all built in the system. You don't write any code or nothing. So because of this, it is giving out tremendous results in the performance of the queries or the applications running on HANA. Next, about having your data in memory, there's nothing I can show you on the screen, but what they say is now you can have 2 TB of RAM in your servers now. If you can go up to that level, but if you see the biggest implementation of HANA now going with Reliance Industries, they're implementing HANA for 4G yeah? with 236 terabytes of RAM. That's the biggest one and in the world. And where the implementation is going on. Yeah. So basically, if you want more RAM, it's all about sizing, multi-nodes. You bring, let's see, each motherboard can have 2 terabytes. If I say like this, if I want 10 terabytes, obviously I have to combine 5 motherboards to formulate my sizing. Yeah. Yesterday I was speaking to some person from HP. Yeah. He's a high-end guy, and he was telling they are the hardware partners for SAP. They were manufacturing hardware for SAP HANA. They had a lot of problems in the server because say they give server sizing like XS, small, extra large, and now customers buy with say 5 terabytes or 10 terabytes, and they're not scale up from there on. They have problems like this. So they get the server 5 TB, and they're not able to scale up the server when they have requirement. So now they have come up with a new server name as Hawk. They were calling it. Hawk, they come up with Hawk servers where they can even enhance it also later. Automatically enhance server. That's what he was saying. And then let's look at what are the innovations from the software side, which is basically resulting in the performance of my HANA systems. Yeah. One is column store and row store. See, store and table. Ultimately, any database you look at, like a SQL Server or Oracle or DB, anything you look at, what do they do? They store data, and you store data in form of what? Table. Yeah. And till now, what are the table we've been referred with RDBMS databases like Oracle or SQL or MS Access? It was all row store tables. Yeah. But in SAP HANA, you do have row store tables and column store tables also. Now, what do you mean by row store table and what do you mean by column store table and what are the advantages and limitations of each of these? That's what we'll have to understand. Okay. See, whether it is row store or column, when you try to see the content of the table, it is always shown you like this. You always get the columns and the rows. The system is not bothered about whether it's stored as row or column. But when I try to say, show me data of this table, you obviously get to see like a matrix. But does it store like a matrix in the backend? In memory, does it store like a matrix? No, right? It does store in a different mechanism. But when you read it, obviously it does formulate the address memories and then collects it and then shows you like a matrix for it. Yeah? Yeah. Now you get to see table like this, but in the internal mechanism, how does it get stored is different. Whether it is row store or column store, when you try to see the content, you would get to see the same way. But when you go about creating a row store table, how does it store internally is different. And if you go about creating a table as column store, how does it store internally is different. Okay. Now let's look at this. If you know what is column of a table, right? Country is one column, product is one column, sales is one column. Yeah. And you know what is the row or a record? Each row is like record, right? Now look at this. Now row 1, India, chocolates, 1000 is row 1. India, ice cream, 2000 is row 2. Germany, chocolate, 4000 is row 3, and this is the row 4. You now understand what is column and what is row. Yeah. Now when I model this table as a row store table, yeah, what does each row is stored in a continuous memory location space. Let's say it takes row 1, chocolates 1000. It will be at one address. Address at memory address or a page. In main memory is always organized in pages. This row will be in one page or some page, 8-bit page or 16-bit page. And this row 2 will be in one memory, and row 3 is at one memory, and row 4 is at one memory. అన్ని కంట్రోల్స్ ఉంటారని కూడా చెప్పలేదు. ఎక్కడ స్పేస్ ఉంటే అది పెట్టుకుంటా ఉంటుంది. row 1, row 2, row 3, row 4. Yeah. So each row is stored in a row ఒక దగ్గర ఉంటుంది. Linked list అంటారు. So each row of a table is stored at one memory, continuous memory location, but row 1, row 2 may be in same continuous, or it could be in different memory address also. But row is together. That's what it is. Okay. And if I say column store, if I model this as a column store table, all the values of one column are stored in one continuous memory location. Even country, all the values of the column country are stored in one memory. All the values of the column product are stored in one memory, and all the values of sales are stored in one memory. Yeah. So as soon as you see, look at this, all column values of the column country in one memory location. All the values of the product is in one memory location. All the values on sales in one memory location. Right? So as soon as I tell you that they've been storing like this, your doubt is, how does system know that India is mapped to chocolates and then this is mapped to, how does it have linking of this? Kada. ఒక్కొక్క కాలం ఓ దగ్గర పెట్టినప్పుడు ఈ కాలంలో ఏ వాల్యూ ఆ కాలంలో ఏ వాల్యూకి లింక్ అయింది అని డౌట్ కదా. నెక్స్ట్, in case of column store, when it does store the values of each column in a continuous memory location, the next point is we need to understand how does it recognize which value of this column is mapped to which value of the other columns. So it does use something called positioning indexing, through which it can recognize which value of this column is referred to which value of the other column memory location. It does use something called positioning indexing. Okay, so if it is column store, it does store memory in this format. If it is row store, it does memory in this format. Do you understand what is row store? What is column store? Now we'll have to analyze these tables, which is better for us. So would I prefer row store or would I prefer column store? Now tell me which one would you prefer? Column store. And let's see. But there is some case. In some cases, row store is faster. In some cases, column store is faster. So we'll have to analyze both now. Now look at this. Yeah, we'll see that. First benefit you should look at is, now look at this. Now when I store as a column store like this, yeah, let's say I run my query like this. Select country from table, which is faster than this. Think logically, Bush. Select country from table. Yeah. Column. When I say select country from table, I'm just trying to read all the values of my country from this table. If it is column store, I would have all my values of this country column in one continuous memory location. Just get to that memory, read those values continuously, and then get back to my results. Yeah. Same on the other side, if you look at row store, I'll have to read this country India value here and go to the address where my row two is stored, get this value. Go to the address where my row three is stored, get the value. Go to the address where my row four is stored, get the value. Now, which is faster in this case? Column storage is faster, right? Let's say my query is this. Why? But let me finish this topic, then you'll understand. Done. See, logically, if you think all my column values are at one place, boss, you're trying to go there and get things right. If it is row store, you're trying to go to different addresses, get the values, and then show you results. So that will be slow when compared to that. So my next is like this. Select star from this table where my country is Germany or where my country is US. I'm saying select star from this table where my country is US. Row store is faster because I'm in this case I'm trying to read entire record where my country is US. Now will I have, if you look at column store, I need to get the country from one memory, go to different memory, get the product as nodal, and again I need to get to another memory location, get the value as what? 500, then give it. But if I use row store in this case, obviously straight away if you go to address where my row 4 is stored, I can just get all the values are stored in that memory, get that record and show you. So until logically, when you're trying to read certain columns of a table, column store is faster. But when I'm trying to read the entire column values, say star, row store would be faster. Is it logical, right? Yeah. Clear? But the question is, okay, Israel is faster. Next, let's say you have a column store table. Let's say you have some table and you would like to use it for reporting. Let's say there are 200 columns and you give this 200 columns model for an end user for reporting. It's an end user, for example, you can drag and drop and see the output. Will you drag 200 columns? 200 columns region wise net sales, region, company code, cost center, what is it you're doing? When you're using this database for OLAP functionalities, are we executing queries like star or certain columns? Certain columns. So which one would I prefer? Column store. So when you're using more for analytics, OLAP analytics, I would always prefer all my application tables as column store table. Clear this? That's one benefit. And one more benefit, look at this. Now, do I show you here as India, Germany, US first? Now what it does not store duplicates like this. For you to understand those are being stored, it will basically store only distinct values. Ante India, Germany, US ante only India, Germany, US pettukuntundi. And this India will be mapped to two columns in this, chocolate and ice cream. But in that column address, it does store India only once only, not the duplicate. So with that, will it reduce the space? Are you reducing the space to store the table? Imagine I have a table with 1 million records. Imagine I've got a table with 1 lakh records, and I've got a column called region. And the cardinality of this region is only 4, north, south, east, west. If I look at this column, I will have 10 lakh values, 1 million values. Okay, but ultimately, if I see distinct values, there are only 4. So in case of column store, if I look at the memory size required to store that column region, it's only 4 cells. But if I end up storing the same table with row store, will I end up storing 10 lakh cells for the same region? Is it a benefit to us? This concept, but what is now we started saying, even though table is denormalized, I don't mind. Since previously we used to have a table as row based, we are more focused on normalized tables, denormalized tables, because if it is denormalized where you have redundant data, it is occupying a lot of space. But if it is column store, each column is stored in one memory location with distinct values. యాక్చువల్ రీజన్ లో 10 lakh సెల్స్ ఉన్నాయి, కానీ అంత కలిపి డిస్ట్రిక్ట్ డూప్లికేట్ పీకేస్తే 4 మిగులుతాయి, ఆ 4 స్టోర్ చేసుకోవచ్చు. So is it doing a lot of compression of database? So because of this again, it does use a lot of compression techniques and reduce the database footprint into HANA bus. Where database నుంచి డేటా ఎత్తుకుని ఈ database లో పెడితే when you do a lift and shift of the data from different database to HANA, it is shrinking the database because of this again, one of the point why the data has been, the footprint size has been shrink down. Clear on this? Yeah. That is one. Now, next question is, let's say, imagine you heard about table BSEG, FI table, it's a huge table, right? So normally when you try to run a select statement onto that, without having where clause on the primary key field, have you ever time observed the performance of it? Is it bad? Yeah. So when you try to run a select statement on a BSEG, which is a huge table, having where clause or a non-key column, as a non-key, because if you use key column in the where clause, obviously it does use primary index, it is fast. But if you're having a where clause or a non-primary key column of a table, the query is slow because there are no indexes on it. Then what do you do to solve this problem? Again, you go about building second index on the. If you still want to have that query, you will eliminate it. But if you still want it, if you want to improve the performance, you will build a second index on that particular column and improve the performance of the select. That's what you do, right? Now, what SAP says here is, in case of a column store table, each column values are stored in one memory location with duplicates being removed. So each column itself will act as an index on the table. Each column itself is like an index. Now you try to, without having second index, you try to have a select on where clause on any of the column, whether it is primary key or non-key column, anything, you would see equivalent performance. Why? Because even though it is non-key column, it is a column, right? And all the column values are stored in one memory location with distinct values pointing out to all the rows. So is it like an index? So each column itself will act like an index. You getting this now? That's why the performance on these tables is really huge. So store చేసే size తక్కువ, performance భారీగా. When you try to read star, it may not work out. But generally for OLAP functionalities, we don't do star many times. Yeah. So what SAP suggests, if you're using column store, even if you have 100 columns, if you need 90 columns, please list out those 90. Only then you would see good performance. 100 ki 90 తేడా ఉందన్న స్టార్ పెడితే ఆ 10 కోసం ఎత్తిపోతాను. So even though it is 90, still list out those 90 columns in the select. That makes it good. That's the way you write about queries. Select star is always bad on the column store table. Did you understand about, okay? This is about reading. So column store is fine when you're trying to read certain columns. Next, I would like to discuss on writing. Now, when you say table, do you also write data back into the table? You read, apart from reading, you also write back data into the tables. You insert new record or you modify a record. Now tell me, straight for my question. I have a table and I'm trying to create a new record into this table, which is fast. Roster. How did you say roster? No. It need not search anything. I'm just creating new record into the table. So what happens? A record this way local peట్టుకోవాలి. In column store, it needs to go to different memory locations and insert the value. So I insert one record saying Nepal, something like say chocolate, and say 600. It has to go to the address where my country is, then insert Nepal. Then go to the address where my product column is and insert some chocolate. Go to the address where my sales is and insert 600. వేరే మెమరీ లొకేషన్ ఒక్కొక్క వాల్యూ పెట్టుకుంటూ రావాలి కదా. అదే రో స్టోర్ అనుకో, టేక్స్ రో, ఫైండ్స్ మెమరీ విచ్ ఇస్ ఫ్రీ, goes and inserts that row. So when you look at inserting data into the table, which is faster than row store. ఆ రో ఎత్తుకు మెమరీలో పెట్టడం రో స్టోర్ అని. అట్లా ఆ కాలం ఆ రికార్డ్ అంతా తీసుకుని ఒక్కొక్క కాలం ఒక్కొక్క మెమరీలో పెట్టుకుంటూ పోవాలి. ఏం ఫస్ట్ రో స్టోర్. So while reading, column store is good. While writing, we are saying row store is better. So it will say, first I'll create row store, insert data, convert table to column store, use it. కదా అట్లా ఈ రెండు మాట్లాడుకున్నప్పుడైతే ఆ థాట్ ఉంటుంది మనకి. ఏంటి First I'll create row store, insert data, then I'll convert to column store, then use it for report. Malli data పెట్టాలంటే మళ్ళీ row store, మళ్ళీ data పెట్టి మళ్ళీ వర్కౌట్ కాదు కదా. So what SAP has done is, so even SAP understood that writing data back to column store table is slow. So what they've done is they've come out with some internal mechanism of column store like this to handle the writing performance on column store. So there is some back end mechanism of column store like this today. It's not straight away like table, for the depth it will be. When you create a column store, table, internally it does create two different memory locations. One is called as main, one is called as delta. Inka main, inka logic ga artham kavalante, understand as if like two tables in the back end. When you create a column store table, internally it does create two memory locations, or understand like two tables in the back end. One is called as main table, or one is called as delta table. Okay, and look at this. And then what happens? The main table is optimized for reading, and the main table is optimized for writing this. And when it's optimized, so main table is more of a column store specific, optimized for reading. Delta table is more of row store combination, which is optimized for writing this. And whenever I write a data into the column store table, we basically inserting into delta storage. Okay, and when you're reading, it does read from main table and delta table. Okay, at regular intervals, do I need to push the data back from delta table to main table? అంటే నువ్వు రికార్డ్ ఇన్సర్ట్ చేస్తున్నావు అన్న, టైం ఎక్కువ తీసుకోకుండా ఫస్ట్ పెట్టేసుకుని డెల్టాలో, ఫ్రీగా ఉన్నప్పుడు ఇక్కడ డెల్టాలో నుంచి మెయిన్లోకి దొబ్బుకుంటాను. బికాస్ డెల్టా ఈజ్ మోర్ ఆప్టిమైజ్ ఫర్ రైటింగ్ and main is optimized for reading bus. So let's say my customer is creating a new sales order. I need to put that into table. If I take a lot of time, obviously it affects my performance. So what he's doing, let's have delta storage, and which is more optimized for writing. It's like row store combination. Let's insert that data into the delta store table. Later, when the system is free, I will start running something called delta merge, which will move the data from delta store to main store bus asynchronously. వాడు రికార్డ్ క్రియేట్ చేసేటప్పుడే నేను మెయిన్ పంపించడానికి చాలా టైం పడుతుంది కాబట్టి ఫస్ట్ డెల్టా పెట్టి డాక్యుమెంట్ ఇస్ బిల్ సేవ్ అని మనం పంపించేస్తాం. మనకి నా కాస్ట్ ఇన్సర్ట్ అయిందని వెళ్ళిపోతాడు. తర్వాత నేను డెల్టాలో నుంచి మెయిన్లోకి దుబ్బుతాడు. ఈవెన్ దో ఐ డోంట్ మూవ్ ఇట్ టు మెయిన్, వెన్ ఐ డూ రిపోర్టింగ్ ఆన్ దిస్ టేబుల్, విల్ ఇట్ ఫెచ్ ఫ్రమ్ మెయిన్ ఆర్ డెల్టా? ఫ్రమ్ బోత్. Reading is done on both main and delta bus, but write operation is done on delta. So do you understand now what is main, what is delta, what delta merge now? It is basic. We'll expand on this topic later. There are different types of merging. Delta merge ante auto merge, smart merge, hard merge, critical merge, different types of merging ante auto merge ante, let's say you create some column table and you say you on auto merge on the table. Auto merge and if you switch it on, what happens? Within your index server, you will have some process called merge dog and over the process. Okay, and merge dog will have some delta merge decision functionality formula out ఉంటుంది. అంటే ఎట్లుంటుందంటే we would have specified when my delta store size is 2 GB అని ఒక ఏదో కండిషన్స్ ఇచ్చింటాం. So what merge dog do is, merge dog will be scanning through across all the tables. Any table which satisfies this decision function of delta merge, it will trigger the merge automatically. That is called auto merge. Okay, and then there's something called smart merge. So we'll switch off the auto merge. నేను merge చేయమన్నప్పుడే చేయాలి. Then that is called smart merge. అట్లా వేరే different types of merging ఉందన్నమాట. Ultimate concept is delta merge is about moving data from delta to main. So with this functionality, am I able to handle the performance of writing also? So major limitation of row store was the problem with writing. Now did I handle the performance of writing in the column store by having the delta and main store logics in the backend? Yes, boss. No, actually, no table. It's all one table. But internally, main is one memory, delta is one memory. And main is more of column store specific. Delta is just like old record row store log. So it is optimized for writing. And then once I writing, then I would start doing delta merge, which will start moving from delta to main. But when I do reporting, it does fetch data from main and delta together. That's what. You mean to say when there is data in delta, the reading would be slow. And then you keep doing delta merge. Generally about cube. What happens when you load data, will after compression will the query be faster? Them. That's why I'm just coming to that. So if you do loading into cube, only when you do roll up, the performance is faster. You have to do roll up. Same way, every time I load into cube, I'll trigger merging, delta merge. After it starts moving from main to delta to main. That's asynchronously. We are not disturbing anything in the reporting level or difference in the performance, but saying during merging reporting is not allowed under. There is only very slight seconds gap of data not available for reporting. Main delta. When you said delta merge, you're saying it is moving from delta to main. Actually, it does create one more main, one more delta. It moves all the data from the main to second main, the delta one to second main, and new delta will start taking data without being the user. No question of being stopped. Very small timing of downtime where it is just moving out data from another set of tables. కొత్త మెయిన్ కొత్త డేటా క్రియేట్ చేసుకుంటూ పోతుంటున్నాను. We'll explore more on that. But for now, column store will have main table, delta table. Delta is optimized for writing. And when you do reading, it does read from main and delta. And the process of moving data from delta to main, we call it as delta merge. Yeah. And the next concept of improving performance of your applications running on HANA is like push down. Now it is concluded that the performance, let's say, any application you do what? You'll have presentation layer, you'll have application server and database server. Let's say you run some ABAP. Let's take ABAP application. Let's say you got database, you got ABAP, and then you got some interface. When you fire out what happens, you like to process some database. What do you do? You write select and read data from database table and put into some internal table, and then you process it and then send the data back to the database or to the front end, right? So now here am I moving data from database layer to application layer, and if it insert back again, I'm sending data back to the database layer. They say 60% of your programming time is spent in moving data from database to application to database. And the concept is, if I can eliminate this timing of data movement, am I improving the performance of the program by 60%? 60% time అదే పడ్డప్పుడు అంత టైం నేను సేవ్ చేసినట్టు ఆ ఫేజ్ ఎలిమినేట్ చేయగలిగితే. సో వాట్ దే డూయింగ్ విత్ మోడల్, normally from the application server, from the database server, we try to application server, then access it. Now what we're trying to do with new model is we're trying to push code to the database. Data ni code దగ్గరికి వచ్చి ప్రాసెస్ చేసేది కాదు, కోడ్ ని డేటా దగ్గర పంపించండి అని. Means we're trying to push as much as possible the data intensive logic deep into database. So you have data in the database. You can write SQL scripting which is closer to your database. Then you don't have to really move across the servers, right? So data is in the database server. My logic is also in the database server. So am I eliminating the movement of data across servers? That's where, so it's about logic. So with the new applications what you're developing, your focus would be on pushing as much as possible the data intensive logic deep into HANA database. HANA database push challenge. For example, you have BW transformations. Do you write a lot of ABAP? So ABAP gets executed with what? In the application layer. So if you write your transformations in HANA, let's say you got BW on HANA, you're implementing transformations for DSO or something. Let's say if you write your transformations with ABAP, I cannot push that logic to HANA database. If I can't push that to HANA database, obviously my performance will not be better. So what I can do, I can eliminate this ABAP and implement something called SAP HANA SQL script export routine. I'll start implementing SQL script for transformations. I'll implement my transformation not with ABAP, no, I implement with SQL script. Now, can my database understand SQL script? Is it now, am I pushing the transformations too deep into another database? That can I get the performance of Adhikans? So in that case, am I pushing code to the database? If I'm writing with ABAP, means what? I'm reading data from database into programming, application server, and then processing it. If I'm writing my logic with scripting is what? I'm pushing code itself to the place where data is there. So it is improving performance. That's where by using the pushing code to the data, you can improve the performance of your applications running on HANA database by eliminating the movement of data from database server to application server. That's a new programming model. That's what they're focusing. Right. Yes, the database. See, transformation is not like taking to any database. Not, let's say you're writing export routine. What is it you do? Are you taking to database? No. You what you do? You have data in the source package. You have in the result package. You're consuming data from the result. Appending records back to the result package that gets into the target. Same way, when you're writing script, you'll have tab, out tab. You go over reading data from in tab, assign the data back to out tab. What are the results you put into the out tab that gets into your target? Well, that's all. Let's say again you're doing some lookups. Normally you write transform with lookups, right? Ammal lookup ఏం చేస్తావు using start routine, you bring in internal table, then you do straight away. In the scripting, I would start writing select the table. I read table directly. For now, just say we can push down the code to the database. That's okay. Then about partitioning of data. Now, do you know about partitioning cube? By year, month, or fiscal period, you do partitioning. Same way, in the database concept, we have partitioning of table. Let's say I've got database table. I can do partitioning. I can partition my table. You know, just splitting up into multiple blocks. I'll have different partitioning like hash partitioning, range partitioning, and different partitioning. And I can go with multi-level partitioning also. I can use hash, range, and the combination of change. Then when we're doing this partitioning, what happens? I can do something like this. Say, create partitions on this table as per number of servers. Next, there will be something main component index server which actually handles your database. In a multi-node architecture, you'll have multiple index servers. అంటే నాకు 4-5 ఇన్స్టెన్స్లు కలిపి ఒక సర్వర్ లాగా పెట్టినాను పెద్ద హ్యూజ్ది 4 ఇండెక్స్ సర్వర్లు ఉంటాయి. అప్పుడు నాకేం కావాలంటే ఐ వాంట్ పార్టీషన్ దిస్ టేబుల్ ఇట్స్ ఇంటూ హౌ మెనీ బ్లాక్స్ అంటే ఎన్ని ఇండెక్స్ సర్వర్లు ఉంటే అన్ని కావాలంటే ఐ కెన్ సే క్రియేట్ పార్టీషన్ సో యాజ్ పర్ సర్వర్ నంబర్ అంటే నంబర్ ఆఫ్ సర్వర్స్ ఎన్ని ఉంటే అన్ని పార్టీషన్స్ క్రియేట్ అయిపోతాయి. క్రియేట్ అయ్యి ఒక్కొక్క పార్టీషన్ ఒక్కొక్క సర్వర్లోకి వెళ్తుంది. అండ్ ఐ కెన్ ఆల్సో ఆల్టర్ ద పార్టీషన్ బై మూవ్మెంట్. అంటే ఇప్పుడు ఇది వద్దు ఈ పార్టీషన్ ఈ సర్వర్ నుంచి ఈ సర్వర్లోకి మూవ్ చేయని కూడా చెప్పొచ్చు. ఐ కెన్ కంట్రోల్ ఇట్ ఎక్స్ప్లిసిట్లీ లైక్ దట్ ఇన్ అ మల్టీ నోడ్ కాన్సెప్ట్. సో విత్ దట్ వాట్ ఐమ్ డూయింగ్ ఇస్ ఐఎమ్ బేసిక్లీ స్ప్లిట్టింగ్ ద పార్టీషనింగ్ మై డేటా అక్రాస్ మల్టీ నోడ్. మల్టీ నోడ్ అంటే నువ్వు ఒకే ఇన్స్టెన్స్ అనుకున్నా ఒక HANA సర్వర్ అనమాట. బట్ నాకు HANA సర్వర్ పెద్ద సైజ్ కావాలి. పెద్ద సైజ్ సర్వర్ కావాలంటే ఏం చేస్తాం? ఒకటి సెంట్రల్ ఇన్స్టెన్స్ చేసుకుని యూ విల్ ఇన్స్టాల్ మల్టిపుల్ డైలాగ్ ఇన్స్టెన్సెస్. ఆల్ దిస్ టుగెదర్ విల్ బి రెఫర్డ్ as HANA సర్వర్ కదా. ఇన్ దట్ కేస్ ఇస్ ఇట్ మల్టీ నోడ్ బస్ అంటే మల్టిపుల్ మదర్ బోర్డ్స్ కలిపి ఒక సర్వర్ అన్నట్టు. ఒక్కొక్క నోడ్ అన్నట్టు. అండ్ ఫ్రమ్ ఈచ్ నోడ్ యూ విల్ హ్యావ్ 1 ఇండెక్స్ సర్వర్. అంటే అప్పుడు నాకు 5 ఉన్నాయి ఇంకో 5 ఇండెక్స్ సర్వర్లు ఉంటాయి. Now, I want to partition my table such a way that one part of data should be in index server 1, one part of data is in index server 2, one part of data is in index server 3, 4, and 5. And when I run my query, I can parallelly read from different partitions or different. And then this is like load balancing. Instead of having pressure on one particular partition or one particular index server, I'll split my data across all the 5 index servers. And when I'm firing out a query, I go over reading data from all the 5 index servers. Am I putting load commonly across all the servers? అంటే ఒక సర్వర్ మీద ప్రెజర్ ఎక్కువ పడి ఉదాహరణ తక్కువ పడిపోవడం కామన్ గా ప్రెజర్ పట్టినట్టేనా? దట్స్ అబౌట్ పార్టీషన్. Getting what I'm saying? And then obviously you'll have like standby and failover. And for example, if certain node fails out, we can have standby and failover nodes. And blades on it. Like you can understand like blade servers where standby failover ఉంటాయి. If something fails out, immediately other node takes care of that. అది concept. Okay, boss? So next, we're getting to, okay. Now we see HANA architecture tomorrow, but now so I just want to show you the course content, what we will be covering into it. Yeah, so you get to know what. We've seen what is HANA past, like architecture is all use case, still is what the introduction part. Then we told you we're seeing something like we're going to use something called HANA Studio, which will be a client-based application to work on to your HANA database. So we'll just get the introduction on HANA Studio. Then we start learning HANA as database first because it's a database, right? We need to learn it as a database, learn about how do we create tables, schemas, fingers, synonyms, and procedures, stored procedures, all this table user different functions, all this column views. All this will be about learning HANA as database first. Yeah. Then we get into basic SQL, structured query language. Yeah. Then by using SQL, the enhancement of SQL will be SQL script. And by leveraging SQL script, I would teach you about stored procedures. How do we write SQL script based stored procedures and how do we debug them? And I go with almost 50 to 60 examples on it. Like, yeah. Then that's about learning HANA as database, yeah, with SQL and all the database artifacts. Then we go learning SAP HANA as a modeling environment where you learn about HANA modeling capabilities, where you go to understand different types of all this, but main focus would be on learning about attribute views, then what? Model analytical views with all the other options into it. We're not getting into that, but there's something calculation views. There will be small options which I will be touching almost every checkbox of it. Marvel. Video little depth at the same way. These are all small options. I'm not touching them now. Now, next, what is it? Next? We get into something called analytical privileges. It is more or less like your analysis operations in BW. How do you control data level security or data level operations? Yeah. Where you can making it fixed static, or you can also make it dynamic by using stored procedures. Yeah. And then we'll get into something called decision tables. Normally, let's say I have a table, I have a record. If I need to update the record, I use update statement. In SQL, I use update statement and update the record. Same way, I can also write an update statements. Instead of writing update statements, I can also leverage decision tables for updating data into tables. Or I can also use it for performing what if analysis. For example, I see my revenues with some price. I just want to see if I increment my price by 10%, what could be my revenues? At the what if analysis compares early, and I can still leverage decision table. So all these 5 aspects would attribute view, analytical view, calculation view, decision table, and privileges. We would cover it as modeling environment. Then we get on to performance tuning and debugging of those. How do I debug those views? How do we tune those views? About understanding about engines like join engine, roll-up engine, calculation engine, different kind of options with visualizing plan and explain plan. We get into that. Then we deal with something called text analysis. How do you process unstructured data? That's important, but still we can spend some time on it. How do we process unstructured data? For example, I get some reviews on a product and I would like to do some sentiment analysis on top of it. I get still leverage. So you'll have different kind of configurations. You can go over creating your custom dictionaries, yeah, and then to get that done. And then we deal with something called full text indexes here, which does create your text analysis. Basically, you have a review, right? It takes a big string and splits into tokens and then gives you analysis on it. Yeah? And then we get on to reporting. See, I'm not teaching you on BO, yeah. I'm just focusing more on Design Studio. And the other part, what I'll do, I'll just show you how do we expose those. So I've got HANA models. How are these exposed to all the BO reporting, like overlap analysis or for IDT or WebD or say Limura or Design Studio? How are these exposed? But Design Studio will spend some time on it. That's a new tool here. And then we get into data provisioning with using BODs. BODs also not teaching you complete BODs. Basically, I'll just spend around 3 to 4 hours on BODs, just showing you how BODs can be leveraged for getting data into HANA. And I'll also focus on how do we integrate BODs to BW as a source system. We can also integrate BODS to BWS. So I will focus on that. And then SLT, we'll get into in-depth of SLT. DX again in-depth and flat file imports, bulk loading, and then smart data access, smart data quality. Again, I get in-depth. Okay. And this is about transporting HANA objects. I'll just show you how do we transport HANA objects with BW powered by HANA. With normal HANA, how do we transport? Then we get into learning about SAP HANA native development. How do I develop? How I only focusing on HANA native framework. How do I create UI5 applications? How do I create services on OData? And how do I create my database table? Here I'm not. My focus is not making it complex because this scenario would be rare. But nakinante, I just want you to be familiar on. See, any application you do, obviously read from database or you insert data into the table. So I'll just show you, demonstrate how do we create some HANA native applications which can read from database and project on the browser. And when I do some changes on the browser, how does it get saved into your database? ఆ రెండు లాజికల్ పట్టుకుని నువ్వు ఎలాంటి అప్లికేషన్ ఫ్యూచర్ నీకే టైం బ్యాడ్ అయ్యి అలాంటి జాబే నీకు వచ్చింది అనుకుంటా ఆ నాలెడ్జ్ తో నువ్వు ఎట్లా ఎక్స్పాండ్ చేసుకోవచ్చు దట్స్ బేసిక్ ఐ వుడ్ గివ్ యూ అండ్ దెన్ we get on to BW powered by HANA, where you learn about HANA optimized queues, HANA optimized DSO. Now, no more HANA optimized DSO. If you have HANA optimized DSO, you'll have to reconvert it back to normal DSO. And then transit provider. How do we consume HANA models in BW? So you've got attribute view, analytical view, calculation. How to consume them in BW? And if I've got BW objects like DSO, cube, or master data, how do I consume in BW? How can I import them as HANA models into BW? Then we have new source system connections with ODP, ODP ECC, ODP SLT. We touch on all this. ODP ECC, ODP SLT, and ODP HANA information use. New type of source system connections are available. We're getting into this. LSA++, advanced DSO, OpenODS view, composite provider. Then out by leveraging ABAP managed database procedures, how will you push your HANA transformations deep into HANA database for performance? Then SAP and near NLS, this I cannot show you practically, but this is only a screenshot. When I say NLS, it's a second, I'll try, but I'm not able to be successful in configuring things. I can show you just a screenshot how they create. It's only about creating a DTB like stuff and running it. Okay. And then workspaces, this is not no more needed. And then SQS you already know. Then so I missed the topic here which you're covering, but there's something migration part. Let's say you got BW on a non-HANA database. What is the pre-migration steps or pre-upgrade steps you do, and what are the post-upgrade and post-migration steps you do, and how do we migrate it to HANA database? అది ఇక్కడ లేదు but it's already there in the topic. Right? And then we get on to ECC powered by HANA, where we get on to search analytics. There is a concept called search analytics where the data sources in ECC itself can be leveraged for reporting on top of it. Instead of, let's say there's a customer who's got ECC with HANA, has got no BW and still wants to do operational reporting. We can use the search analytics and new one, and where many of the customers are really using this for reporting of HCM and HR reporting. They're using this concept. Then HANA Live. So there are RDS solutions given by SAP like ready-made calculation views, ready-made views delivered by SAP for ERP, CRM. So how do we get that HANA Live, and how do we understand those HANA Live ready-made views? How can we customize private views or reuse views or query views? So this will be the complete course content which we'll be dealing with. And tomorrow we'll spend some theory part on architecture, and then just architecture and getting to know the components. Then from there we'll get on the system on HANA Studio, start working on its database. Fine. Thanks.